with these webinars. So today I'm going to talk about machine learning, and in particular I'll be talking about recommender engines. Thank you for participating in this. I'll first talk a lot about just machine learning in general and what that is and what it's useful for, and why we think this is a really good thing to think about for many businesses around Scandinavia. And then I'll exemplify it first with a very general machine learning experiment and a demo, and then particularly with recommender engines. I'll tell you what a recommender engine is and why I think it's a really cool thing to use for those that maybe have already used machine learning to some extent and would like to take it to the next level even. So it's a little more of a deep dive. If someone has heard me talk before, then some of in the start, some of it will be something you have heard before, maybe. But towards the end, I hope there'll be something new for you as well. Okay, so an overview of machine learning. I'll talk about what machine learning is, and secondly, what the process is with machine learning. Why machine learning is more than just maths and some algorithms and some computer skills, but also a more soft skill actually. And finally, I'll do one or two demos depending on time, probably two. Okay, there's only one demo transition, I promise. We like this very much. I hope you'll forgive it. The Innofactor, just in brief, is a big Nordic IT company. For those of you that may not know us, we are present in all four of the Nordic countries, headquartered in Espoo, just outside of Finland, but a big presence in Sweden and also in Norway and Denmark, with approximately 600 employees spread around these countries. Most of them in Finland, obviously. We are about 50, 60 employees here in Copenhagen and in Aarhus. So in Denmark total, we are some 50 or 60 employees. We here in Denmark, we focus mainly on Innofactor in general focuses 100% on Microsoft. Everything we do is Microsoft Enterprise solutions, and we have a very close connection to Microsoft and a very good collaboration with them. Here in Denmark, we do flexible collaboration, as we call it, which is a lot about SharePoint, Office 365, and good ways to collaborate, all the new ways of doing that. Business productivity is a lot about what you may know as BI, making sense of data. This is what I'm presenting on today as well. Using data in new and clever ways, good reporting, that kind of thing. And finally, we are one of the leaders in intelligent cloud, meaning Azure, understanding what Azure does, how to make security and work well and securely, and how to price it and scale it in a good way. That's our three focus areas. And the rest of Innofactor in the Nordics are also a big presence in CRM solutions and ERP solutions, customer relations and economy solutions, where they are very good in the other three Nordics as well. Alrighty, a bit about myself. Whoa, what is that? That is just to say that I actually have a background completely outside of consulting. I have a PhD in astrophysics from that's more than 10 years ago now. This is the planet we found we discovered around this very odd-looking named star, Ogle 2005 Bulge 390. We found a planet around that, and it was published in Nature. But my focus was hunting planets around other stars, just like the Sun has Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, Pluto. All the other stars that we see on the sky, they actually have planets too, and we can find them in clever ways. That was my topic. Since then, I have decided only apparently to work for companies with blue logos. So I worked for the big Scandinavian bank that many of you probably know, Danske Bank. And also for Topdanmark, a relatively small insurance company, and then for Innofactor for the last 3 years-ish as a consultant, and now I'm leading a team of machine learning experts who do advanced analytics or machine learning, whatever you want to call it, for all sorts of customers, and we find this a very interesting topic. Alrighty, let's look at what machine learning is. This is a word that is used a lot, and every time I go to a talk like the one I'm giving today, people spend the first, 15 minutes discussing what machine learning is and how it relates to advanced analytics and data mining and artificial intelligence and neural network and statistics and all these buzzwords. I find this discussion really stupid and completely a waste of time. Mainly because there is no definition of these words, advanced analytics and artificial intelligence and machine learning. So really, if you feel confused and if someone starts telling you, oh, that's because you're talking about data mining and really you should be talking about machine learning, tell them to stop it and just worry about how you can use your data in better ways. And do not worry about whether you are talking about one buzzword or the other. It really doesn't matter. Actually, it's a very old discipline. And whenever people find out, oh, it's just the same so machine learning is really just data mining, which was a buzzword 10 years ago, then people invent a new buzzword just so it's not discovered that it's actually the same thing over and over. This is a very old discipline. Banks have been doing data mining or machine learning for 30 years for credit scoring. This is the business I'm coming from before being a consultant. And there we had been doing it for 30 years for credit scoring. Now for the last 5-10 years, the buzzword has been machine learning, and probably more and more it's becoming data science. But really, to be honest, it's the same thing. So don't worry about that. And this is just me making Venn diagrams of different people and their definitions of these buzzwords. And as you can maybe see, all the Venn diagrams are different. No one has a clear definition of what these buzzwords mean. And I think that underlines that spending time on any distinction between them is irrelevant. And if you feel confused about these words, and that's really my point here, don't worry about it. It's not important. The thing is how you can use your data in clever ways, and don't worry about whether it's one word or the other. It really doesn't matter. I hope that's okay to you. My definition of one of the buzzwords, or all of the buzzwords, however you want to put it, is that I think of machine learning as using historical data to say something about the future. I'll give many examples for the next 20 minutes. But using some data to say something about the future is machine learning. A good way to at least start with machine learning is to use structured data, meaning data that fits in a table or several tables. Maybe we join them up into one table, but data with rows and columns. That's the best way to start with doing machine learning. So if you want to start thinking about using machine learning in your business, think about where you have some structured data, where you have some historical data that you want to know what happens in the future. I have several examples coming. If you're thinking, but I don't have structured data like this. I have tweets or images or sound or movies or Word documents or something like that. Okay, we'll help you. What you'll probably do is to make your data into structured data. That's actually a better way rather than having a machine operate on all sorts of mixed bags of files and formats and streaming data and what have you. The first task is usually in a machine learning project to convert it into streaming data. A lot of people want to tell you that you can just make machine learning on all garbage, but the rule still applies, garbage in, garbage out, also for machine learning. All right, a few examples just to what does using historical data to say something about the future. What does that mean? Well, I have a few examples here for you to maybe frame it. I already mentioned credit scoring, but let's get back to that. One very common example is forecasting. We have some historical data on economical key numbers like revenue or profit or number of people who will buy something or products sold or whatever, some economic figure that we have historical data on. How did it go in time? What was our revenue last month, the month before, the month before, the month before for the last, 10 years? And now we'd like to know what will the revenue be tomorrow what will the stock rate be tomorrow? What will the price be tomorrow of some product? This is a very common machine learning task. As soon as you mention stocks, you know that they do financial markets. They do everything they can with data to find the last little digit, the last little improvement on their data and their price quotes. So forecasting is a very common use for machine learning, using historical economic figures to say something about where they will be in the tomorrow or in the next second or in the next year, whatever your time horizon is. Forecasting always a good thing if you have historical data on your key figures and you would like to know what those key figures would look like tomorrow or next year. Forecasting is a very good idea and with a high value for most businesses. I have a terrible joke. It's a very, very bad joke. But it's very often that we have historical data where we just want to know what is different. And the bad joke is coming in a second. I'm terribly sorry for the bad joke. But we may want to know what will be different next. What's the outlier here? It's called outlier detection. What is different in this data? What looks different than the norm? We have some gray mass of data, and then we want to know what looks different. In this case, you can clearly see that there's an egg here, that the white egg is different from all the other eggs. But actually, what we could ask is, how different is it? For example, and here comes the bad joke, it's not a giraffe. I apologize. But the point is that for some machine reading, maybe we want to know when is the reading so different that we should be worried that the machine is about to break. Well, one thing is to be told this reading is different. Well, all the readings are probably different, but this reading is very different. Okay, then we will start worrying. And that could go for fraud cases as well. We have a lot of transactions, and all the transactions are different. No transactions are two transactions are the same, but maybe one transaction is so different that we want to investigate it further. And in this case, we can use machine learning, outlier detection, or anomaly detection is also called, to find what is different. Let's skip the bad joke. I already mentioned here, fraud is one case that we have been working on for several customers. Whether people pay money, or whether people get money, or whether people write pieces of information to someone, and that information could be wrong. In all these cases, there's a chance or risk that people will be cheating, that people will be doing something they're not supposed to do. And we've been working both with people paying money and people getting money, and we've been working with people looking up things in a system. So for all the municipalities with the new GDPR regulations, for example, people are not supposed to look up information that they're not entitled to. You're not supposed, as a doctor, to look up your ex-wife or your colleague or your neighbor, your children, even yourself. You're not allowed to look up in a system. So we can actually detect with machine learning who does things in the systems they're not supposed to, or who receives money they're not supposed to, who forgets to pay the money they're supposed to pay. These are extremely good cases for machine learning, because we have historical data on who have been caught doing something they're not supposed to, and we can do that to predict the future, who is likely to end up in court if we investigate them. Very good machine learning case, also because the money involved is usually quite big. That the amount of money people are cheating is often very good. So if we can just find very few, it's a really good business case for almost any work. A few more cases that I always mentioned. I always hinted at predictive maintenance. Can we identify a machine that's about to break before it breaks down? In almost any case, it's a really, really good thing. Having machines or production equipment or trains or cars or planes or anything grounded because they don't operate is very expensive if we didn't know it before it happened and it just happens mid-flight. It's a very bad thing. If we can predict it before it happens, then it's usually a lot cheaper to repair it. before it breaks down. Also a production machine. If we can do plant maintenance on equipment, it's a lot cheaper than having a whole production floor stand still because some little thingy broke. One thing we all where we all experience machine learning is shopping analysis, a bit analogous to what I'll be showing you later. You have bought this, maybe you would like to buy this as well. Actually, I'll come back to that. That's what you would use recommend engines for, so let me show a bit more about that later. And finally, a very good case for machine learning is churn, as it's called with a fancy word. Customers that leave our business, subscribers that leave our business, employees that leave our business, some people that are paying us or working or doing something day in and day out, month in and month out, paying their subscription, and all of a sudden they stop paying. Can we identify them up front? It's usually quite cheap to give them some incentive to stay. Maybe we just need to call them and say, how's it going? Rather than when they have left to go out and find a new customer. It's a lot more expensive to acquire customers compared to keeping them on board when we have them on board. So churn analysis is always a very good case. You just need 5 churn customers to stay. Big case we made was for the University of Copenhagen. Identifying students that are about to drop out before they drop out is a really good case because it's very expensive when students leave the university, and it's not just having a chat with them for half an hour is no price at all. So it's a really good case. Another case with customer focus is obviously which customers should we approach to get them on board. So marketing or sales approach to machine learning. What customers should I contact? If I just take the phone book, there's a lot of people to call, but maybe I can do it more intelligently based on what I know about the customers and what I know about my historical data on which customers tend to buy something from me or subscribe or become clients of some sort. That's a very good case also if you have data about your potential customers also. Then you can use this for direct marketing and which customers you should approach. Okay, I'm sorry, I cannot read questions along the way. I think I'll take questions afterwards. That's probably questions already. You're very welcome to write them already now. When my presentation is done, I think we'll take some questions if you have any, and you're more than welcome to write them already now. Okay. Just very briefly, I'll not go into this, but just mention that when you think about machine learning, you think about maths and algorithms, and a lot of people who hear that I do machine learning, they ask me, so what's your favorite algorithm? Do you prefer support vector networks over support vector machines over neural networks, over Bayesian algorithms, over blah, 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 blah? Really, it's a relevant question. It's an important thing to discuss and to know about, but it's not the most important thing at all. I teach both at the Danish Technological Institute, and I teach customers on an individual basis, or maybe 10 customers from the same company. I teach machine learning. And I spend about maybe 2 or 3 days on this process thing, and only a half a day is spent on these algorithms. It's a detail. It's not an unimportant detail, but it's a detail. Whether to use one algorithm over the other and how they work, what the in communication in a neural network, how it works is something I'm happy to talk about, but it's not important, and it's not my focus in machine learning. How to actually set up the data so it's relevant for machine learning, and how you make sure you don't include data that the machine learning problem cannot handle is a mistake I see every time I go out teaching. Every time I go out teaching, I see people using the wrong data for machine learning. Data sets that include rows that cannot be included or columns that cannot be included. I see that every time. And it's a very, very difficult thing to understand how to do this the right way, how to set up a business case that makes sense for machine learning, and actually the most important thing, the validation, how to understand whether your machine learning model works, whether you've actually been able to make predictions that are sound, is something I spend a lot of time on, and much more than the maths. and how to communicate these problems. One thing is that you understand that you've made a good model. Well, I have a PhD in physics. I'm a clever guy. Well, yeah, but you need to also make sure that the business understand how clever you are and that you've actually made a good model. And this is something that you spend a lot more time on, and that make machine learning projects fail a lot more than having chosen the wrong neural network type. That is never the problem, in my experience at least. Okie dokie. I'll skip over this whole going through that. Oh, funny connections. And then just make a brief demo on how machine learning is done in practice. The main what I hope you will take away from this little machine learning demo is that it's with modern tools is very easy. A lot of eggheads like myself go around and tell people that they need to be very clever to do machine learning, and that these different algorithm choices are important and difficult. In truth, with these modern tools, it's very easy, because if you choose the bad, for example, a bad algorithm, you just try another one, and it takes 2 minutes, and you try the next thing and the next thing and the next thing. That's not where machine learning projects fail with these modern tools. Like the one I'm presenting here is actually Azure Machine Learning from Microsoft. It's a cloud-based tool, so that means it lives inside my browser here. You can see I'm in a browser. And I haven't downloaded anything. I've just subscribed to this service from Microsoft in Azure. It's free for as long as you want to play around with it. Really, if you want to put things into production, and if you want to have more data inside your experiments, you need to pay. Not very much actually. It's trust me on this. It's a very cheap tool, but compared especially to its competitors. And it's free to get started, like so many other of these click-around tools in Azure. Really a nice thing. What I like about this is for demo purposes, it's down here. For demo purposes, it's really good. It's also the thing I use for teaching, because it's point and click, and you don't spend all your time worrying about syntax problems and where am I missing a semicolon or plus or minus. This is a minimal experiment, actually an experiment from our university case. That's why I won't show you in data. But you can see this is a minimal experiment. It's 1, 2, 3, 6, 7 little buttons here dragged into an experiment, and I press the run button, and I've made machine learning. Really, when I have the right data, it will take me 3 minutes to make a machine learning experiment. And it's at least a first stab at a machine learning experiment to see whether I have data that can be used. Okay, so the promise was to talk about recommender engines. What is a recommender engine? Contrary to the other things I've talked about that have mainly been classification problems, putting things in box A or B, recommender engines, for example, putting persons in the cheater or non-cheater box, or churning customer or non-churning customer box. This is quite different. It recommends items for, in this case, persons. So based on what some people have liked and what some people have not liked, and historical data on that. That's why it's machine learning, right? We use historical data on what people have liked and have not liked. We use that to predict what people will like, or what things we should recommend to specific people. This is and let me just show you how relatively easy it is, and then maybe we can just spend 1 minute on how it would be relevant to maybe some of your businesses. So here I have some data on some customers. Let's just the good thing about Azure Machine Learning here, everything is point and click. If I anywhere in my data flow want to see what data looks like, I right click on it and I use visualize. I see what data looks like at this step in my process. This is the important data on customers. We have where they live and whether they are smoking, how much they like alcohol, their dress preferences, their marital status, height and weight even, and their budget for restaurants, and their personality and religion even, and all sorts of information about persons. We also have some information about American restaurants here. There are 130 different restaurants, And we have 21 different information pieces on these customers, including their name and some geometry on geography on where they are placed, also address information, whether they serve alcohol, the dress code, accessibility, how easy it is to get there for disabled persons, the price range, the URL even, and whether it's in a closed or open area, and all sorts of different, whether it's a franchise, a restaurant, true or false, and so forth and so forth. A lot of different information. Okay, so that's a lot of background information, and we could in principle use this alone on what customers look like, which restaurants. That would that's one way of making a recommender engine. But in this case, and that can be done on its own. But in this case, we even have some data on what persons liked what restaurants. So in this case, user ID 1077 gave a rating of 2 to restaurant 135085, and the same person gave a rating of 2 to this thing, and this person gave, and so forth and so forth. We have 1,161 ratings of different combinations of customers and restaurants. Okay. Now, just to illustrate how easy it is to work with these things, let's set up a recommender engine first, because I'm even as clever as I may think I am, I need to prove to people that my model is good. For that, I use some data to make machine learning, and then I make about 20% of the data I'm going to use for validation, as called, showing or illustrating how good my model was, or investigating how good my model was. That is called validation, and for that I need some data that will not be used as part of the training the model. So I split the data here into 80% used for training and 20% used for validation. Okay, but I need to train my model. I do that with the train Matchbox recommender engine model. I put that here, and I use my training data set, put that in one, and here it says I need training set of user features. Okay, that's probably our customer data. And I need some data on items. In this case, that's our restaurant, and use it like that. Sorry, we started just 2 minutes late. I'm gonna run 2 or 3 minutes over. I hope that's okay to you, and then we'll take questions for those who want to stick around. Alrighty. Actually, I should probably use this select columns in dataset mode. Whack, doing, and I'll take that again, because not all the columns, as you maybe saw, are relevant for my machine learning experiment. Something like, why are you angry? Select, oopsie, I need to select columns in dataset. Oopsie, sorry. Some of the columns, let's look what columns we have available, and maybe we can investigate if some of them make sense or not. User ID we need to pair with the ratings. People's longitude and latitude is probably too much detail to use. I'll skip that. Smoker, drink level, dress preference, does that say something about what restaurants they will like? Yeah, probably. Ambience preference, their means of transport, marital status, how many kids they have, their birth year, their interest, their personality, their religion, maybe. Does it say something about what the restaurants they like? Maybe, yeah. Okay, I'll skip color. Their height and weight is probably good, but I think it's too detailed. Budget sounds like a more good thing to know about someone's restaurant's preference. Similarly, for the restaurants, what do we think says something? We need the ID for pairing with the ratings, the latitude and longitude. Yeah, but probably too detailed. The name of the restaurant, I think it's too detailed. Let's give it the address, city, too detailed. It could be used country. Yeah, not a bad idea, but I'll skip it. Alcohol, whether they have a smoking area, dress code, accessibility. Yeah, sounds like good. Price range, yeah. URL, too detailed. Ambience, whether it's a franchise, the area, yeah, that's good. Whether they have what other services they have, yeah, okay, let's go for that. Alrighty. So we've chosen what columns we think say something about what customers like the restaurants, and also what restaurant features say something about which customers like them. Let's use that, and then use that to train a model. And when we train the model, we need to compare the model that we make up here with our validation data. So we take the validation data from up here and put it into our score model down here. Scoring means just that we compare a model with some data. In this case, it's the validation data. I put the model in, and then it also needs to know the user features and the item features, in this case the restaurants. And I apologize, it becomes a few more buttons and maybe is easy to see, but I hope you can at least get an idea that it's not complicated. And in my teaching, I spend a lot more time on this. And we evaluate the model with the model. There. And that goes into the other bin, actually. Apologies. And this, this one up here goes in there like this, and we can run the experiment. Did that take 3 minutes, plus me talking at the most, to set up a machine learning experiment? It runs for about a minute or two. And we have made a machine learning experiment. We have even validated whether our model works or not down here. So not only have I made a model, and not only can I say, yes, I'm a clever boy, I have made a good model, but actually I'm also able to prove it to the business by getting some summary statistics on where the model creates scores on items that where it knows the truth. It knows what people recommend, what restaurants people like, and it can compare that with the model's prediction of what they like. And we use that to make some summary statistics. The summary statistics is not very meaningful in this case. Actually, it's just a number between 0 and 1, where 1 is a very good model, a very good comparison between validation data and the actual outcome. So 92% is a really good model we've actually made in about 3 minutes. Okay, finally, 1 second on that. I hope you can imagine that this would be relevant to you as well in your organizations. Not everyone runs a restaurant business. Or a restaurant recommendation site. How is this relevant for me? I think where it's most obvious is people that handle cases, a high volume of cases in, for example, in a call center, having recommendations on next action in a call center is a very obvious case that I think you should think about. When people show up in our business, they call our organization, they call our hotline. Maybe we can have 3 recommendations ready for the case handler to send them in the right direction. On websites, when people go to our website, depending on who they are, can we predict what they're actually looking for based on what they've done before, and use that to predict what we should offer them, what links we should show them on our webpage, or maybe offer them the right phone numbers to call inside organizations, instead of just presenting them with a big phone book. These kind of things, I think, is the most obvious. If you're not running a dating site, then this is obvious as well. But not many people are running dating sites. A lot more people have customers calling their hotlines or going to their website, where the customers are tired of just being presented with the same, whether they are banking CFO or someone looking for unemployment benefits or the whole third person. They get presented the same thing on your website. Maybe you should be clever and present something for that particular person to increase your user experience. Okay, I hope that's a very brief inspiration. As I said, I teach this to anyone who wants to listen in, for example, 2 or 3 day, probably 3-day courses, both at the Technological Institute and also for individual persons. But if you're a few persons, I would recommend that you talk to me or one of my colleagues, and we set up a course on 2 or 3 days in your organization on machine learning and how to get started with these things, and how it could benefit your business. So we not only listen to me talking, but we actually start using your data in a 3-day workshop rather than just a teaching session. Okay, I hope that's it. And I'd like to thank you for your attendance and your patience with me getting started with this thing. If anyone does not have questions or do not want to hear what other people have to say,